all of you. So today I am going to talk about a shuttle system in the respiration. So what is actually shuttle system and what is the purpose of this shuttle system in the respiration? You know, in the respiration NADH2 and FADH2 is take part. NADH2 and FADH2 is forming in the mitochondria, but all the NADH2 is not forming in the mitochondria. FADH2 is okay, it is forming in the mitochondria, but NADH2 is forming in the glycolysis also. In the glycolysis is taken place in the cytoplasm. So how the NADH2 from the cytoplasm is transported into the mitochondria for further process of the respiration. For that purpose, there are two shuttle systems is given. Out of this, the shuttle system one, that is known as the Malate Aspartate shuttle system. And this Malate Aspartate shuttle system, it is operating in the case of the muscles, heart and liver, and also in the kidney. And another shuttle system that is called the glycerol 3-phosphate shuttle system. Glycerol 3-phosphate shuttle system is operating in all the plants and also in the nerve cells and some muscle cells. This glycerol 3-phosphate shuttle system is operating. So what is the difference between these two? Let us see first the Malate Aspartate shuttle system. In the Malate Aspartate shuttle system, there is no loss of energy. Energy is not loss, but in the case of the glycerol 3-phosphate shuttle system, there is a loss of energy. How the energy losing? Why the energy is not losing here? See here, in the Malate Aspartate shuttle system, NADH first oxidized to NAD. NAD plus it oxidized to NAD, and at the same time the oxaloacetate is actually converted into malate, and this malate transported through the outer membrane of the mitochondria, then through the inner membrane of the mitochondria. Yes, of course, between the intermembrane space, and then it cross the inner membrane of mitochondria, and this malate is again converted into oxaloacetate. At the same time, this NAD is transported along with that, and NAD is converted into a reduced form, that is NADH. So this NADH is produced with the help of the malate dehydrogenase present in the matrix side. So here there is no loss of energy. Actually, the NADH is transported into this matrix and without losing any energy. Only some conversion is taken place. So in this process, energy loss is not available. And this oxaloacetate converting into aspartate crossing the inner membrane, interspace, outer membrane, and this aspartate again converting into oxaloacetate. Then this cycle is operating continuously. So here automatically when the cycle is operating, NAD formed in the cytoplasm is transported into the matrix of the mitochondria. So here without using any energy. So this type of the shuttle system helping to obtain 38 molecules of the ATP from one glucose molecule without losing any energy. So this also taken place in the case of the aerobic prokaryotic organisms, bacteria, where also 38 ATP molecules are total profit from the one molecule of the glucose. So this taken place in the heart and also in the case of the liver and also in the case of the some muscles without losing any energy. So this is the shuttle, Malate Aspartate shuttle. Then say another shuttle that is known as the glycerol 3-phosphate shuttle. Glycerol 3-phosphate shuttle taken place in all the plants and the nerve cells and some of the muscles. See here what happens here. These two NADH2 or NADH is reduced, oxidized to NAD, and at the same time dihydroxyacetone phosphate is converted into glycerol 3-phosphate. And this glycerol 3-phosphate crossing the outer membrane, intermembrane space and inner membrane, and it is converting into FAD. And this FAD is reduced to FADH2 and glycerol 3-phosphate converting into dihydroxyacetone phosphate. This reverse transport into the cytoplasm, and this DHAP, dihydroxyacetone phosphate, again using for the cycle to operate. So here from one NADH2, a FADH2 is formed. So one NADH containing 3 ATP molecules. Out of the 3 ATP molecule, one FADH2 containing 2 ATP molecule. 2 ATP molecules are lost there. So here this conversion is causing the loss of the 2 ATP molecules, or the 2 NADH2, 4 ATP molecules are lost. So total out of the 38 ATP molecule, 4 ATP molecule will lose, and the net profit is only 34 ATP molecule. So here loss of the ATP molecule, shuttle system second, glycerol 3-phosphate shuttle system, 4 ATP molecules are lost, and this taken place in all the plants, and some of the muscles also it taken place, all the plants and nerves and some muscles, this type of the shuttle system is operating. If shuttle system is not operated, the NADH2 formed, 2 NADH2 formed in the cytosol during the glycolysis cannot transport into the mitochondria. So that is a great loss. Out of this great loss, some loss is bearing, and the remaining is converting into ATP. So the profit in the case of the shuttle system second is 34. In the case of the shuttle system first, it is total 38. It also taken place some of the aerobic bacteria also, because aerobic bacteria there is no difference in the cytosol and mitochondria, and both are taking place in the same, that is the cell membrane. Okay, so that is the shuttle system. There are 2 shuttle systems. So let us take what is the amount of the energy present in the glucose. One glucose molecule containing 1292 joule energy. Joule energy is present, or it is near about 309.7 kilocalorie energy is present in the one glucose molecule. Out of this, it producing the ATP, one ATP having 34 joule energy is present, or it may be 8.15 kilocalorie energy is present. So let us calculate the energy efficiency of the photosynthesis. The energy efficiency of photosynthesis, that is ADP converting into ADP plus inorganic phosphate, it is producing the ATP. So and here 8.1 kilocalorie energy. This energy 8.15 kilocalorie energy is saving in this ATP molecule. So what is the efficiency of this photosynthesis? So there are let us take 36 ATPs producing. So we take a 36, not take a 38 because some losses there. So this take a 36 ATP because here 2 ATP is losing. So 38 minus 2 ATP for 1 NADH to 1 here 1 NADH 1 NADH2 1 FADH2 means 2 ATP is lost. So here 38 minus 2, that is 36 ATP is produced. So we consider this 36 ATP into 8.15 kilocalorie. So that is equal to 291.6 kilocalorie energy is producing containing the 36 ATP molecule. We are considering this one. The loss is considered. Then what happens? What is the efficiency of the photosynthesis? Efficiency equal to 291.6 kilocalorie. That much energy is stored, and the one glucose molecule contains 686 kilocalorie energy already. But we getting only this much. Already the glucose contains 686 kilocalorie energy is present. That is equal to 42.5%. So this multiplied by 100% you will get, that is 42.16%, 42.50%, 42.50% energy is conserved by photosynthetic mechanism. So this amount of energy is very high. This is the efficiency of the photosynthesis. No such machinery, no such discovery in the world that is giving this much efficiency. Even the sophisticated vehicle that will give only 25% efficiency by using the petrol or the purest petrol. But this efficiency is 42.5. If you take 38 molecules, this is the 36. If you take 38 molecules, this efficiency become near about 44.58% efficiency you will get. So this is the one of the very efficient mechanism of the energy conversion. There is no such efficient mechanism is available in the nature. And this also taken place in the lowest temperature, low temperature, and low pressure without any applying the high pressure, without applying the high temperature. And this efficiency, the photosynthetic mechanism is so efficient that it cannot be emulated, it cannot be reproduced by using any kind of the technology in the world. Okay, that is the shuttle system in respiration. This is not directly involved in the NCERT syllabus, but it is very essential for again for the NEET examination. Okay, thank you very much.